Okay, when we're looking at similar figures, one of the most important things that we're going to talk about is what we call the scale factor. Scale factor is what we use to go from one shape to another shape. So in this case, I'm looking at triangle ABC and triangle EFG. Now, what this statement up here tells me is that these two are similar triangles. So the first thing I have to recognize is which sides go together, because in order to find scale factor, I need to know that. Well, luckily, the names can tell us. AB is going to go with EF. So I can look at those first two letters and see that 2 goes with 3. And then the same way, BC goes with FG. So I can see right there from the name. So I can tell that these sides go together. The reason why that's important is because that's going to let us set up a certain relationship that we have when we're talking about scale factor. And that's looking at end over my beginning. What this does is lets us figure out what was multiplied or what we multiplied by to get from one shape to another shape. So end over beginning, for example, if I'm looking at my arrows are pointing to the right, pointing to this side, so my end number would be 3, and my beginning number would be 2. I can reduce that, and I always should reduce it, and it reduces to 1.5. If I try it the same thing with my other two sides, I can see that my end of 6 over my beginning of 4 also reduces down to 1.5. So what this tells me is that my scale factor to get from the small shape up to the bigger shape is 1.5. So what that tells me is I multiplied all these sides from my smaller triangle, ABC, by 1.5 to get to the bigger triangle. So my big things that I'm pulling out of this is to find scale factor, we do end over beginning, and we reduce that ratio down in order to find what we multiplied by.